Hello. All right, let's get started here. So the first problem says write an equation for an ellipse with a major axis from the point 5, -2 to -1, -2, and a minor axis from 2, 0 to 2, -4. So I've already sketched these out here. Mainly the only reason I sketch it out is because I'm a more visual person, and so if I sketch it out, I can see that this is a horizontal ellipse. So what that means is that the longer side is going to be below the x part of our equation. So our equation is x minus h squared over a squared plus y minus k squared over b squared equal to 1. So if this is a horizontal ellipse, that means that this is going to be my bigger side. And since it is my bigger side, that means it is along my major axis. Bigger side, longer side, however you want to say it. Maybe we should say longer side. There we go. And so then that means that B is our shorter side. So it's the side along our minor axis. So all we need to do is we need to know what A is, we need to figure out what B is, and we need to know what our center is. Our center is HK. So when I look at the points here that I have, I can kind of eyeball it, but the way to know exactly where my center is I just calculate that full distance from each point. So that's a total distance of 6 units, and so half of that would be 3, so 1, 2, 3 lands my center right there. So that is the point 2, -2, and that's my center. So when I write my equation, I'm going to have x minus 2 squared over a squared plus y minus -2 squared over b squared equal to 1. Now a is the distance of my longer side along the major axis, which I already calculated here is a distance of 3. So a is equal to 3. And so b is going to be the distance on the shorter side, which is 2. So b is equal to 2. So I'm going to go ahead and replace those there. I have 3 and 2. So when I rewrite my equation, just to simplify it a little, it's going to become x minus 2 squared over 9 plus y plus 2 squared over 4 equal to 1. For my next problem, I went ahead and graphed the points as well. They gave me the two vertices, that's this point and that point, and they gave me the foci, which is this point and that point. So from what I can tell, because these are the vertices, this is the vertex here and there, what I've been given is the major axis. So I know that this is going to be a vertical ellipse. And what that tells me is that when I write this equation here, actually, let's switch this. This is going to be my longer side over here. It should be underneath the y-coordinate because it's vertical, and our y-axis is vertical. So we need to figure out the center. We can do that the same way. You just take the distance from one vertex to the other vertex. It's a total distance of 10. You just split that in half, so that's 5. So 1, 2, 3, 4, 5. That brings me here at the point, which is 3, 1. that is my center. And I need to figure out my A. So A comes directly the distance from the vertex to the center. So I know that distance is 5, right? If the whole major axis is 10, then I know that my A is going to equal half of that, is going to equal 5. And then we need to figure out what B is. However, weren't given any information about the covertices, so I can't just look at the graph and figure out what B is. Instead, I'm going to use the formula c squared is equal to a squared minus b squared, because I've actually been given my c value. The c value is the distance from the center to the foci. So if I count that out, that distance is 1, 2, 3. So I know that my c is equal to 3. What I can do with this information now is just plug it in to that formula. So I can see that 3 squared is equal to 5 squared minus b squared. That's going to be b squared equal to 25 minus 16. Sorry, not 16, 9, and then the answer is 16. 25 minus 9, so b squared is equal to 16, which means that b is equal to 4. Let's do a little double arrow there. Alright, so b is equal to 4. That means when I go to write my equation, I have everything that I need. I know my center is 3, 1, so I've got the 3 there. I know that b is equal to 4, so I plug in 4 there. And k is 1, and a is 5. So when you look at this equation, you should have the bigger number underneath the y value, which we do have right here. The 5 is bigger than the 4. So this works because we have a vertical ellipse. So from here, I can just simplify, turn that 4 squared to a 16, and that 5 squared to a 25. And there is my solution. Alright, so for this next problem, we are given the covertices, which I've gone ahead and plotted. So if the covertices are horizontal like this, I automatically know that this is going to be a vertical ellipse, because that means our longer side is going to be kind of along the x-axis or the y-axis. So if I write out my equation, this is going to be my shorter side underneath x, and my longer side, which is a, is going to be underneath the y. So what the other part we were given is the length of the major axis. So that's the entire axis from vertex to vertex. It has a length of 18. So what I need to do in order to find those vertices is I first need to find the center. So to find the center, I can figure out that the length of my minor axis, this is a length of 12. So half of that would be 6. So I'll just count out 1, 2, 3, 4, 5, 6. And that's going to be my center. This would be the point -2, 6. So there's my center. That means that I can now figure out my vertices. And technically I don't even need to know what the points are, because now that I know my center, I can plug my center in here to the equation. This will be -2, and this is 6. So I've got that far, and I know that my b is 6, right? We calculated this distance right here to be 6. because the total length of the minor axis is 12, so I can change this to 6. And so they already gave me the length of the entire major axis. So I know that my A is just going to equal this 18 divided by 2, which is 9. So I can go ahead and just change that. But just so we can see what the ellipse is going to look like, I'm just going to go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That brings me to 15. And then I go down 9, and so I'm going to be down here at -3. So we have this kind of vertical ellipse going on here. And from here we can just simplify. This will become x plus 2 squared over 36 plus y minus 6 squared over 81 equal to 1. And this should make sense. So we should have the bigger number underneath the y part of our equation because it's a vertical graph, and we do, so that works out for us. The next example, we are taking this general form and turning it into the standard form. Already we should know our general form rules and be able to classify this here because we have different coefficients, but they are both positive. I know that this is an ellipse. So let's see if we can get this to be in the standard form of an ellipse. What I need to do is complete the square. I'll put all my x's together, but in this case I've only got one x right here, so I'm going to have that on its own. It's already a complete square. And then I have my y's. I'm going to leave a space for that to complete the square, and I'm going to move the 32 over to the other side. And in order for me to complete the square over here with the y's, I have a coefficient of 4 in front of the y squared, so I have to factor that from here and from this term, and I'll keep that there. So this will give me y squared plus 2y plus blank equals 32. So what this means is, now when I go to complete the square, 2 divided by 2 is 1, 1 squared is 1, but when I'm going to add on the other side, I'm going to multiply this 1 times this 4, which gives me 4. So that's what I'm adding to the other side. Remember, this is already a complete square, and I'm going to change this to y plus 1 squared equal to 36. It's almost in standard form, but I need to have a 1 on this side, so I'm going to divide everything by 36. And this will give me x minus 0 squared over 4 plus y plus 1 squared over 9 equal to 1. And on top of that, I can classify what kind of ellipse it is because I can see that my bigger side is underneath the y part, so I know that this is going to be a vertical ellipse. For this next problem, I'm looking at the squared terms, and they both have the same coefficient, and they're both positive, so I know that this is going to be a circle. And we're going to need to complete the square because we have 2 x terms there, and then we have our 2 y terms, and I'm going to add the 6 over to the other side. Complete the square just by dividing by 2 and squaring that, we get 1. I don't know why I'm rewriting that, I can just put it in here. 1, and then negative 6 divided by 2 is negative 3, and you square that, you get 9. So what we need to do is we need to add both of those values, 1 and 9, to the other side. So this will become x plus 1 squared plus y minus 3 squared equal to 16. Now this is already in our standard form for the circle, because over here I can already see my radius is 4. because 16 is 4 squared. Box that up. Our last one here, this has different coefficients, and they're both positive, so I know that this is also going to be an ellipse, but just by looking at it, I can't determine if it's going to be vertical or horizontal, so we have to put it in standard form in order for us to figure that out. There's only one x, so that's already a complete square, and the y's, I'm going to have to complete the square for that. The 60 gets moved over. 4 divided by 2 is 2, 2 squared is 4. Add that to the other side. So this will become y plus 2 squared equal to 64. Now because this is an ellipse, I'm going to have to divide everything by 64. So this gives me x minus 0 squared over 4 plus y plus 2 squared over 64 equal to 1. And again, because I can see that this is the bigger number, I know that this ellipse is going to be a vertical ellipse. It didn't ask us to determine what kind of ellipse, but went ahead and did that.